Very good morning. Myself, I'm Mohan Venkata Suprasad Chandaluru, Assistant Professor, Narayana Engineering College, Godur. Today, I'm going to give a big presentation on QNX Neutrino Real-Time Operating System Architecture. Deep diving into this architecture, this is the outline that I'm going to present in front of you today. So, introduction to QNX RTOS, followed by the microkernel architecture, and then process manager, protected memory and address space, scheduling, IPC mechanisms, resource managers, and then conclusion. So coming to the introduction to QNX Neutrino RTOS. First, the RTOS is real-time operating system. Why real-time operating system? So why real-time operating system means basically we all know that operating system is the one which is going to act as a bridge between the user as well as the computer hardware. So whatever the hardware related things, whatever the things the user is going to interact with the system or machine, without an operating system nothing will be done. So operating system plays a crucial role in any embedded system application. So QNX is a microkernel based real-time operating system which is designed to deliver an extremely reliable and predictable behavior. In the sense, whenever something crucial matter is going to happen by using a bit or embedded system, so the system has to respond very quickly to the user's command. So whatever the command that is going to be given by the user, the system has to respond within the specific timeline decided or developed by the programmer. So in such scenarios, a real-time operating system has to be involved. So such real-time operating system, this QNX is also. So it is widely used in the safety critical and mission critical embedded applications. As we already discussed that embedded application, so this QNX RTOS is going to be used. So it is the response time has to be very critical, and it has to reach the deadline, guaranteed deadlines, even in heavy workloads. Even the work is heavy, it has to reach or it has to meet the deadline. So specifically this QNX RTOS is used in different such applications like automotive applications like different ECUs. So ECU is nothing but electronic control unit, and ADAS system. So ADAS system is nothing but automatic driver assistance system. So in the automotive field, in the vehicles, in order to communicate between one ECU to another ECU, this RTOS plays a major role in order to give a specific deadline, in order to reach the specific deadline. So basically this QNX is fully of a POSIX compilant. So POSIX stands for portable operating system interface. So it acts as an interface. Next, key characteristics of QNX. Basically, QNX is a microkernel architecture. So, what the differentiation between the microkernel and monolithic? In the followed next coming slides, I'm going to discuss that. So, this is a microkernel architecture. It means that whatever the essential services required or whatever the essential services run by the kernel, so all those kernel services will be run in separate address space, whereas the user services will be run in the separate address space. It means that both user as well as kernel services will be separated, which have different memory space. So it is very robust, very resilient, very high reliable operating system, and it supports user space device drivers, making drivers restartable without rebooting the system. Without if any error occurs, instead of rebooting the particular system, but just by restarting the system, it can rectify the error. So for such cases, this QNX plays a major role. So ensures a real-time deterministic scheduling, and it also provides a low latency. Low latency in the sense the difference between the deadline, as I mean difference between the time that which it requires to complete the particular task and the actual time it requires. So both the differentiation is very less. So it means that the latency is also very less, and it also cross platform portability. It is having the QNX is having cross platform portability. And coming to the design philosophy of the microkernel, QNX microkernel, so it is minimal. The cost required to design the QNX microkernel architecture is very minimal and very efficient and effective operating system. The most essential functions which are available in the kernel space of QNX architecture are scheduling, inter-process communication, next interrupt handling, memory protection, low-level address translation, timers, clocks, high resolution counters, everything will be available in the QNX microkernel space. So by using all these parameters which are available in the kernel space, we are going to make this QNX architecture is very effective and in an efficient way. So the design strictly separates the policy in the sense the security policy will be involved in the QNX architecture. The user space as well as the kernel space will be separated. And so that is the major thing in the kernel level of architecture. And if you observe the diagram here, it is a monolithic based architecture. It means normal Linux or Unix based systems, whatever the previous systems that are going to use, those are using the monolithic architecture. So what the monolithic architecture is, if you observe this, the yellow color, so here all the services which might be provided by the user, which might be provided by the kernel. So user interface, scheduler, memory allocation, network stack, application, serial drivers, disk drivers, file systems, whatever it might be. If the user wants to interact or open the file or read the file, write the file, close the file, or else if the CPU has to be scheduled for a particular task, if the CPU has to be scheduled for particular processing, if memory should be allocated to the particular process to do its processing, if the memory has to be deallocated, so those are the kernel services. So all those kernel services, as well as the user wants to read something, open a file or read a file, those are the user services. All those services, both the services will be in the same space. What it may happen, for suppose if a serial driver crashed, so all are equipped into a same space, what it might be, or entire machine will be crashed. So that is the disadvantage in monolithic architecture. This particular disadvantage will be overcome in the microkernel architecture. How it is going to be overcome in the microkernel architecture? The next diagram is going to be the microkernel architecture. This is the microkernel structure. If you observe, only the essential kernel services, that are process manager and microkernel, will be clubbed and making as a kernel space, that is called proc NTO, process manager. So this process manager is going to serve the kernel services, provide the kernel services. And if you observe the other perspective, other line, so the device shell, kernel shell, the application process, the user interface, the device drivers, the network stack, the data bus, whatever it might be, whatever the small processes, all those processes will be in the other space. It means here the user services and kernel services will be separated or differentiated, so that if at all one particular shell is having some disturbance or creating some disturbance, or one particular interface is creating some disturbance, one particular device stack is creating, or network stack is creating, or bus is damaged, so in such scenario we are not shutting down the entire scenario. Only that particular kernel or only that particular process will be killed, or only that particular system will be crashed, and remaining system, the entire system will be in a safer side. So that is the major advantage of the microkernel architecture. And here the same what we have discussed as of now, the benefits of the microkernel. One is the fault tolerance. The security policy is also high, because whenever user wants to access the things without a security, which means we are providing some credentials, user level, admin level, next server level, so all those securities will be included. So modularity, whatever the higher process, the higher process will be divided into small chunks, and we are making the entire process will be divided into modular programming, and this modular programming is the essential part and main benefit of the microkernel architecture. And scalability, more scalability is there. Debugging is, it is very easy to debug. Why? Because we are in debug, what we will do, we will create some breakpoints, and we are going to check line by line, so everything will be available in the QNX architecture. So, and this is the process manager, as I already discussed in the previous diagram, proc NTO, process manager, as well as the kernel, all these two comes under the proc NTO, and this proc NTO plays a major role in the microkernel architecture. So this is about the microkernel architecture, I mean the QNX architecture. And thank you so much for giving this opportunity. Thanks a lot. By this I'm concluding this. Thank you.